Howdy PreCal, it is Miss Kosh, and we are now solving polynomial equations. And so I'm going to start this by maybe reminding us, maybe teaching us how we name different kinds of numbers. And so the first one is, it has the symbol that looks something like this, and these are called natural numbers. And I have seen some books. Natural numbers are the counting numbers, but some books include 0 and some books don't. So the way I've been teaching it for the last 15 years is that I do include 0 because my IB books included 0 in that category. Okay, so I'm going to make a Venn diagram, and the smallest group in the middle here are the natural numbers, and that would include things. I would say it includes 0, it includes 4, it's the counting numbers, it includes 6, 17, that's my birthday, June 17th, and so these are natural numbers. Okay, the next set of numbers that we're going to talk about are called the integers, and for some reason, I don't know why, we use the letter Z with an extra line. I don't have a good answer as to why. If anyone wants to come up and figure that out for me, that would be amazing. Okay, so with the Z, with the integers, it's all natural numbers also fit inside the group of integers. And the integers now, something that is an integer but not a natural would be like -11 or -1, 2, 3, 4 or something like that. So these are whole numbers but now negative. So these are the integers. Then we get to a set that's a little bit bigger than that. And that, I may have not saved myself enough space. Okay, these, the next one is, these are called, okay, so these were natural. I should write that down. These are integers. Q means rational numbers. And the rational numbers with this Q is anything that can be written as a fraction. So all of our integers can be put over 1, and so they become fractions like that. But this would like include 1/2 or 1/12. Okay, it could be negative 3, 4, 5 over 6, 7, 8, 9. I don't know. It's anything that can be written as a fraction. Those are integers. They can be positive. I lied. Those are not integers. It's an integer divided by an integer that gives me a rational number. Okay, and then the next set that's a little bit bigger is one that you've seen the notation for, and that's real numbers. So all rational numbers are also real numbers, and our real numbers things that are real numbers but not rational are our irrational numbers. And so like the square root of 3 is irrational, or pi is irrational, or e is irrational, or something like 37 pi minus root 2. I don't know, I just made something up. Those are all irrational but real numbers. Okay, then the next is the set, we can sometimes see it with a C with an extra line, and those are the complex numbers. And so the way I like to visualize that is that all of our real numbers live inside the world of complex. So here is complex, but then part of the complex are just the imaginary. So the complex, and then, so here's how I see it. You've got the real, and then you've got something, an imaginary would be like 4i, or I root 7. But it would be a complex number when you have something like 14 minus 3i. This has a real part, 14, and an imaginary part, the minus 3i. Okay, so this is kind of often in the form a plus bi. And so the real numbers would happen where b is equal to 0. And the imaginary numbers, I would argue, happen when a is equal to 0. And then complex is the world that includes all of it. Okay, so sometimes we will factor, and we will make sure we factor just over the rational numbers. And then sometimes we can factor over the real numbers, and sometimes we can factor over the complex numbers, and it just gets kind of crazy. But hopefully that puts all of our numbers in context. And is every number a complex number? I had to Google it the other day, and the answer is no. Not every number is a complex number, but I don't know it. So that information is beyond the scope of what I am familiar with. Okay, so then we have this polynomial function. If I expand it all out, and it's got all these different terms, I can find if it has rational coefficients. Now, not every polynomial has rational coefficients. Like we saw, if I see something like x squared equals 4, set that equal to 0. What was I saying? Not every, I don't know. Okay, never mind. This would have non-real zeros, but it has rational coefficients. I'm not sure what my point was. Oh, then every rational is 0. Okay, not every polynomial. That's what I was going with. Okay, x squared plus 4, if that equals 0. Here's my polynomial, x squared plus 4. It has, if I go to solve, I have to subtract 4, and now I do the cheer, square root, plus minus, and I get x is equal to plus or minus 2i. This did not have rational zeros. These are complex zeros. These are imaginary zeros. And so this doesn't always, but this is saying that if it does have rational zeros, it has to come in the form p over q, where p is a factor of the, no, q is a factor of the coefficient, the constant coefficient, and p is a factor of the leading coefficient. No, I'm saying that wrong. I was questioning myself the other day. Basically what happens is we take the factors of the constant and we divide it by the factors of the leading coefficient. So the constant is p and the leading coefficient is q. Okay, so in this particular scenario, I have this 2x squared minus 4x plus 6. I would, to say what are the factors of 6 are 1, plus or minus 2, plus or minus 3, and plus or minus 6. And I would have to divide it by plus or minus 1 and plus or minus 2 because those are the factors of 2. Okay, and so ultimately, if this guy right here has rational coefficients, it would come from, well, I can take plus or minus 1, 2, 3, and 6 and divide each of those by 1, which gives me where I started. And then I can do divide by 2. I can have a plus or minus 1 over 2. 2 over 2 is 1, which I already wrote down. And then I have a plus or minus 3 over 2. And then 6 over 2 is 3. So this set of 2, 4, 6, 8, 10, 12 numbers are the only set, if that polynomial has rational coefficients or rational zeros, it comes from that list. Okay. All right. So next thing we need to do is practice dividing. So we're going to do a little bit of long division. Oh, notice what they did here for us. They, I don't remember solving this problem before, but I must have, because I think I already did this answer key. We had to put them in order. And I noticed that there are no terms with x. And so I'm going to divide it right like this. Okay, and so I begin by saying, what is 2x cubed divided by x squared? Well, that is 2x, and I like to write it in that column where this whole column here will have just be my terms with x. Okay, so then I'm going to multiply it back, and I'm going to get 2x cubed, and I'm going to get a minus 6x. Okay, and so then what happens? I have to subtract. This is gone. I have this negative x squared that I have to bring down, and a plus 6x, and a plus 25. And now I'm doing a negative x squared divided by this positive x squared out front, and that gives me a negative 1. Okay, and now we're going to multiply back, and I'm going to get a negative x squared and a positive 3. And then we're going to change our signs, subtract. And so this gives us a 6x plus 22 as a remainder here. And so, I just dropped my pencil. What I end up getting is that this will be equal to 2x minus 1 plus this guy divided by, what were we dividing by? X squared minus 3. If you think about it, if I'm dividing like 37 divided by 2, okay, 2 goes into 3 one time, I multiply back, I get 2, I subtract, I get 1, I bring down the 7. 2 goes into 7, how many times? 17, that's not a 7, that's a 17. It goes into 16 8 times, so then this is 16, when I subtract, I have a remainder of 1. So this ends up being 18 and a half. So 18 and 1/2 is great, but we would probably prefer to write 18.5. Okay, we did the same thing here. We took that remainder and put it over what we were dividing by. Hopefully that made sense. Okay, you need to go away. Why am I not seeing delete? Well, cut, whatever. Okay, the next one, let's start with blue. I see 15x squared divided by 3x, I get a 5x, and then I multiply this back, 15x squared, and a positive 5x, and then I like to change colors, subtract. This comes down as 3x minus 12. 3x divided by 3x is a positive 1. 3x times 3x, this is a 1. Subtract. Hang on, let's change signs. I mean, not signs, colors. Subtract, subtract. This is gone. This gives me a negative 13. And so this is minus 13 over, what was it? 3x plus 1. So this becomes our answer. Okay. Synthetic division is a little faster, but it works really well when you're dividing by something linear. Okay, I don't know what this is. Ignore that. I don't know why it's there. Okay, so on this one, I'm gonna need. Okay, now it's in the way. We have our x to the fourth term, we have our x to the third term. I don't see an x squared. I need to hang on to a 0. I have my x term and I have my constant. And then this is the factor, and so it would have a 0 of negative 2. So I'm going to divide by the negative 2. So then I bring down this first number and I multiply. 3 times negative 2 is negative 6. I add those and I get negative 7. Negative 7 times negative 2 is a positive 14. I add those, I get 14. Oh, I'm going to have to multiply in my head. I get a negative 28. Combine that to negative 23 times, this is a positive 46. And then this gives me a 45 right here. So what does this mean? This means, well, 3x, what was I went from x to the fourth to, if I take x to the fourth and divide it by x, I'm going to get x cubed minus 7x squared plus 14x minus 23. This 45 was my remainder. What was I dividing by? I forgot. X plus 2. And that's the answer to that division. Okay. Over here, I have a 1. Oh, no x squared term. And there's a 2, so I can bring down this, multiply, get a 2, add these, multiply, get a 4, add those, multiply, and I get a 7. So what is this equal to? It's equal to x squared plus 2x plus 1 plus 7 over x minus 2. Okay, so now we're going to start, we can do what's called we can use synthetic division to figure out the remainder. So like I could say, if I want to do f of 5, this becomes 4 times 5 squared minus 16 times 5 plus 9. 5 squared is 25. If I have 4 quarters, that's 100. 5 times 10 is 50. 5 times 6 is 30. That's minus 80. Plus 9, I see 29 is how I have to plug this in, or to plug and chug. And my synthetic division lets me do this, and then I just start doing synthetic division with the 5. I write down the 4, I get 20, I get 4, I get 4 times 5 is 20, I add those, I get 29, and this remainder is the same thing I get when I plug this in. So, I might require you to do it a certain way, but I'm more concerned that you do good math to a good answer, so you could pick either way. Okay, let's see. After that division, you know what? We're going to come back and make this next part another video. So, like, subscribe, comment, let me know how I can help you. And the only way to learn math is to do what? It's to practice. So, go practice.